The accumulation of advanced glycation end products, AGEs, is frequently cited as a central hallmark of aging, blamed for stiffening tissues, damaging proteins, disrupting DNA structure, and accelerating oxidative stress. AGEs form when sugars, particularly glucose and fructose, bind non-enzymatically to proteins, fats, or nucleic acids, a process known as glycation. As these modified molecules build up, they impair cellular function, trigger inflammatory signaling, and degrade tissue elasticity. Age accumulation is especially prominent in diabetes, cardiovascular disease, neurodegeneration, and kidney dysfunction, all conditions that are more prevalent with advancing age. This has led many to conclude that glycation is simply a natural consequence of getting older. But a more rigorous biochemical view suggests something different, that excessive glycation is neither inevitable nor genetically programmed. It is a result of persistent dietary imbalance, specifically poor glycemic regulation combined with a lack of anti-glycation micronutrients. Aging, in this light, reflects not decay, but unaddressed nutritional debt. The primary driver of AG formation is chronically elevated blood sugar. When refined carbohydrates and simple sugars dominate the diet, glucose levels spike repeatedly and dramatically. These spikes increase the likelihood that sugars will bind irreversibly to cellular proteins, producing early glycation products and ultimately AGEs. Unlike enzymatically regulated metabolic reactions, glycation is spontaneous and indiscriminate. It targets essential proteins like collagen, elastin, and hemoglobin, damaging their structure and reducing their biological activity. In tissues with low cellular turnover, such as skin and vasculature, these damaged proteins linger for years, contributing to the visible and functional signs of aging. Yet this process is largely a function of diet, not time. Age formation is significantly lower in individuals who maintain steady, moderate blood glucose levels, even in older age. This alone suggests that glycation is not aging per se. It is a preventable consequence of dietary excess. However, glycation is not only about sugar intake. It is also about nutrient protection. The body has natural defenses against glycation, enzymes and antioxidant systems that identify and neutralize early glycation intermediates before they can do irreversible harm. Pyridoxamine, a derivative of vitamin B6, plays a direct anti-glycation role by trapping reactive carbonyl compounds that form during sugar breakdown. Zinc, a key structural mineral, contributes to glyoxylase activity, which detoxifies harmful glycation intermediates, such as methylglyoxal. Alpha-lipoic acid and carnosine are two other nutrients shown to inhibit AG formation or promote their breakdown. When these protective compounds are abundant, glycation is controlled and damage remains minimal, even in the presence of occasional sugar intake. But when these nutrients are consistently deficient, as they often are in diets heavy in processed foods and low in whole, mineral-rich sources, the protective systems falter and glycation damage accumulates unchecked. This leads to a simple but profound insight. Many of the cellular features attributed to aging, stiff membranes, misfolded proteins, metabolic inflexibility, can instead be viewed as symptoms of glycation burden that have been allowed to progress in the absence of nutritional countermeasures. Cells appear aged not because of a predetermined clock, but because they are saturated with damaged proteins and dysfunctional scaffolding. This is not inevitable. It is biochemical feedback, a reflection of unmet nutritional requirements. Studies in both animals and humans support this view. Diets low in refined carbohydrates and high in polyphenol, zinc, magnesium, and B vitamins consistently show lower levels of circulating AGEs. In populations with traditional, whole food diets, such as the Okinawans or certain Mediterranean groups, age accumulation is markedly delayed and age-related diseases are less prevalent. Even when AGEs are already elevated, interventions such as carnosine supplementation, glycemic control, and pyridoxamine intake have been shown to reduce AG levels and mitigate their effects. These are not miracle therapies, they are nutritional corrections. Importantly, glycation damage is not always visible until it crosses a biological threshold. Many individuals, particularly in modern societies, carry a high burden of glycation for years before overt disease or disability appears. By the time symptoms are evident, vascular stiffness, insulin resistance, or cognitive decline, the underlying molecular scaffolding has already been compromised. Yet even at this stage, nutritional strategies can restore some degree of function by slowing further glycation and supporting protein repair. The key is not just sugar restriction but micronutrient repletion. Thus, aging marked by glycation is best understood not as deterioration programmed by time, but as a preventable and partially reversible process resulting from chronic nutritional imbalance. When sugar dominates the diet and the body's natural defenses are starved of their cofactors, glycation accumulates like rust on iron. But just as rust can be prevented or slowed by changing the environment, so too can AG formation be managed by nourishing the body's internal chemistry. Aging, in this paradigm, becomes less of a mysterious curse and more of a logical outcome. Too much sugar, too little zinc, too many spikes, too little pyridoxamine, too many insults, not enough protection. This is not just theory. It is observed in populations, confirmed in trials, and supported by decades of biochemical insight. The cell, when adequately supported, is remarkably capable of resisting glycation and maintaining functional integrity well into older age. Therefore, the burden of ages is not a fixed legacy of time. It is a variable, dynamic process, one profoundly shaped by the choices we make daily. To reduce it is not to fight aging, but to feed renewal. And in doing so, we uncover a deeper truth, that aging is not a disease, but a reflection of how well or poorly we have nourished the machinery of life.